As we start talking about area between two curves, the first example that I want to give is the area between two curves that don't intersect. And in this example we have y equals sine of x and y equals x. Now I try to choose two curves that we should be able to picture and to realize that they are not going to intersect, especially on the interval between pi over 2 and pi. And so I start off with a graph of sine. Now I could easily, having the computer here, I could easily give you a perfectly drawn graph of sine, but I don't want to do that because when you're doing these problems you're going to need to be able to come up with these graphs without a calculator. So let's just assume that sine of x looks like this, and the zeros are going to be at x equals 0 and at x equals pi. Following this we have the graph of y equals x. Now, it may not be obvious from the graph, and especially because I've drawn a graph that is probably not accurate around 0, that the graph of y equals x is tangent to the curve of sine of x at x equals 0. And past that point of 0, it never really intersects. It never intersects the curve y equals sine x again for x greater than 0. Now, that may not be clear, but at least we can see that at pi over 2, the graph of y equals x is significantly higher than the graph of sine of x. So at pi over 2, the graph of y equals x is equal to pi over 2, obviously, and that's half of 3.14, which comes out to be roughly 1.57. Whereas sine of x at x equal pi over 2 is just equal to 1. So since we know that after pi over 2, sine of x heads downward towards pi, but y equals x continues to head upward. So we can see that between pi over 2 and pi there will be no point of intersection. And what we want to do then is to find the area enclosed by the two curves between pi over 2 and pi. So we're looking for that area in orange. Now, whenever we're looking for area between curves, it's important to remember our basic formula, and that is that the area between two curves is given by the integral from a to b of f of x minus g of x dx, assuming that f of x is greater than g of x. That means that the curve, whatever we call f of x, is above g of x. We always do top minus bottom, high minus low. And so in this case, our top function is going to be y equals x, and our bottom function is going to be y equals sine x. So we set up an integral from pi over 2 to pi. The function above is given by y equals x, and the function below is given by y equals sine x. Solving that integral then will give us the area enclosed by the two curves between pi over 2 and pi. Since there's no simplifications to be done with the integrand, we just look for the antiderivative of x minus sine x, and that's going to turn out to be x over 2, x to the second over 2. And the antiderivative of sine is negative cosine, and since we're looking for the antiderivative of negative sine, it's going to be positive cosine. And we're looking for this value. We want to evaluate this at pi, and then minus evaluating it at pi over 2. Again, usually with these problems I'm going to set up my two sets of parentheses there. The first one is going to be the integrand evaluated at pi. The second one is going to be for the integrand evaluated, the antiderivative of the integrand evaluated at pi over 2. So x squared over 2 is going to give us pi over 2. Cosine of pi is negative 1. Pi over 2 squared is going to give me pi squared over 4, and over 2 is going to give me pi squared over 8, whereas cosine of pi over 2 is 0. And so simplifying, I get pi squared over 2 minus pi squared over 8 minus 1, which is 3 pi squared over 8 minus 1. And it's sufficient to leave the answer like that. An estimate using the calculator of that final part would just be 2.701. And once again, this is an example of the area between two curves where the curves do not intersect, but we're told between which two points or which two vertical lines we're looking to assess that area. And that's the end of this example and this video.